Good afternoon, everyone. Today we're going to solve a trig equation with the tan function. And if you look at the fundamental structure of our equation, this looks a lot like a quadratic equation, right? The only difference is that we don't have an x squared and an x term. We have a tan theta squared and a tan theta term. We can think of it exactly the same way. We can also do a substitution of letting x be equal to tan theta and then actually writing this with x and resubstituting over at the end, but we don't have to do that either. We're going to look for all solutions from negative infinity to infinity, which means all solutions for theta in degrees. And so let's get started. First off, we know how to solve quadratic equations, right? We're going to factor them using decomposition because we have a coefficient of the x squared term or the tan squared term that is not just equal to 1. And so that means we're going to think of two numbers that multiply to make negative 12, 3 times negative 4, and simultaneously add to make negative 4 in the middle here. So those two numbers are going to be negative 6 and positive 2. And so we're going to decompose the middle term of negative 4 tan theta into negative 6 tan theta and positive 2 tan theta, the same way we always have with quadratic equations. So that means we'll have 3 tan squared theta minus 6 tan theta plus 2 tan theta, right? This is where we see the result of factoring the two numbers that multiply to make negative 12, and add to make negative 4. Negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. Exactly what we want. And so we can finish that off. Minus 4 is equal to 0. And as always, with decomposition, we factor the first two terms, and then separately factor the last two terms. And so to factor the first two, we'll have 3 tan theta, and then tan theta minus 2, and plus we factor the 2, and inside the bracket again, we have tan theta minus 2, and we know we're on the right track because there are two brackets containing the exact same expression. And so now we can go ahead and factor all of the stuff outside of the brackets, being 3 tan theta plus 2, and inside the brackets, tan theta minus 2 is equal to 0. And now we know that for this to be equal to 0, either term has to be equal to 0, which means if 3 tan theta plus 2 is equal to 0, then we have that tan theta is equal to negative 2/3. And likewise, if tan theta minus 2 is equal to 0, then a tiny bit of algebra shows us that we need tan theta to be 2. And now we're going to think of all the places on our unit circle where we achieve either of these two results. So let's use our calculator for these ones because I definitely don't know these off the top of my head. Let's do tan theta. Right, so maybe we should actually write that out. So theta is the inverse tan, of course, of negative 2/3, and theta is the inverse tan of 2. Right, now let's be mindful of all of the solutions that are going to exist in all 4 quadrants for our solutions, and then we can consider adding revolutions around the unit circle to get all possible values. Okay, so for the inverse tan of negative 2/3, let's start off with that one. We're going to get negative, we get negative 33.69. Negative 33.69 degrees, which is, if we want to write that as a positive angle, we certainly can make it like that, but just to make it easier on ourselves to consider both possible solutions, let's write this as a positive angle, right? So negative 33.69 is the same as 360 minus 33.69, right? And so really, that's the same as 360 minus that, which is 326.31 degrees. And now let's consider where our tan is negative, right? What we're finding here is what angles of theta provide us with a tan ratio that is negative 2/3. Tan, if we consider our unit circle, quadrant 4, quadrant 3, quadrant 2, quadrant 1, this solution resides clearly in quadrant 4, right? Let's maybe make a note of that. So that should be around here at 326.31 degrees. Here our tan is negative, right? Because in quadrant 4, sine is negative and cos is positive, meaning tan, the ratio of their quotient, is negative, okay? Tan theta is negative 2/3. We also get a negative tan in quadrant 2. And so now all we need is their reference angles to get the equivalent result over in quadrant 2. So the reason why it's helpful to start off by writing it, this is why our calculator gives this solution to start off with. We get a reference angle of 33.69, right? This can act as a reference angle. Then the same way that we can go down by 33.69 degrees from the positive x-axis to obtain this solution, we can do the same in going up from the negative x-axis, right? So we can go up by 33.69 degrees, and we know that tan is also negative here, right? Tan theta is negative, right? Negative, negative. And so thinking of our reference angle of 33.69 degrees, we know that the negative x-axis is our 180 degrees, and so 180 minus, that should be subtracting, right? Like, it's a reference angle of 33.69, and so we're gonna go 180 minus 33.69, and what does that turn out to be? 180 minus 33.69, that takes us to 146.31 degrees. And so that's going to be our second solution for our first theta value here. So we'll have, again, 146.31 degrees, okay? Now, those are only two solutions that are emanating from our first, let's say, tan value of negative 2/3. We're going to get two solutions here. Now we're also going to get some solutions from the tan thetas of the 2 part of it. So if we look at the inverse tan of 2, now we're going to find an angle of 63.43 degrees, which is going to lie somewhere in quadrant 1, somewhere around here, 63.43 degrees, right? Because we know that tan theta is positive in quadrant 1, where sine and cos have the same sign, and also in quadrant 3, where the sine and cos are both negative, and so have the same sign, so tan is positive. And so this 63.43 conveniently acts as a reference angle as well. And so if we want to find that same solution down here in quadrant 3, we can think of its reference angle, and so that means 180 degrees plus 63.43 degrees. And now if we go ahead and write that down, that's going to be around, this solution is going to be around 243.43, simply adding 180 to our first one. And so we get 243.43 degrees. And now we have two solutions here, and we know that we would continue getting those solutions with every revolution of the unit circle that we would do, going clockwise or counterclockwise. And so, since we're dealing in degrees on an infinite interval, we can be sure that we're going to capture all integer number of revolutions around the unit circle as well. And so our solutions would be theta is equal to, let's start with 146.31 degrees plus or minus 360 degree times k, where k is any integer, any element of the set of integers, that bubbled z symbol. And then we can go ahead and express every other solution in the same way. 326.31 plus or minus 360 degrees times k, again k being any integer. And likewise, for our final two solutions, 63.43 plus or minus 360 degrees K. And finally, 243.43 plus or minus, again, 360 degrees time K, aka some integer multiple of revolutions around the entire unit circle for any integer value, okay? And this would be our entire set of solutions here. I hope this helps. I hope this starts to make connections between sine, cos, and tan in the unit circle, catching all solutions that exist on whatever interval we are dealing with. And if you guys have any questions, comments, suggestions, please do leave a message below. And thanks for watching.